as we go. And so this workshop is an across the board type workshop. It's from introductory level stuff to some fairly advanced stuff. As I was looking at composing the content, I could have you follow me, but then I would get about 20% of the content that I would like to cover for you. Or I could have slides basically all prepared of what we're going to talk about and show you little tricks of the trade and things like that, but not have you follow me. And I took this latter thoughts that instead of doing, me do it, you do it on your computer, they would be better usage of everyone's time if we went through a model course on Python. I'll talk a little bit more about that in just a moment. So that's going to be the methodology. I'm going to show you lots of little slides here and there and show you where to get information and those type of things. So that's how I will proceed with this. But let me start by asking you some questions. And so use the reaction button down there on the right-hand side by raising your hand or not. So we're talking about Python. How many of the people in this workshop have never really worked with Python? If you'd raise your hand, please. Okay. Give it a few more moments. All right, it looks like most of you have done a little bit with Python. So let me ask another question here. So if you lower your hand, have you wrote, how should I phrase this? Do you consider yourself an experienced Python programmer? Let me ask the question that way. So if you'd raise your hand, if you consider yourself an experienced Python programmer, I'd appreciate it. Okay, so it looks like most of us are somewhere in between having never used it and not really considering ourselves an experienced programmer. Okay, so what I'm going to describe is the purpose of this workshop is to make you dangerous in Python, not to know enough to be able to program hundreds of lines of Python, but instead to make you an automator of tasks. So what am I meaning by that? If you are going out there and you're doing the same thing over and over, and it takes 8 mouse clicks to do it. If we could write a script in 5 lines that would do that same task, and all you have to do is change the name of the file in it, that would be a much better usage of your time. One of the files that I'm going to show you near the end of what we did is to take a state map and pull every county out as an individual county map. And then to use those maps to clip rivers, roads, features like that, and to do it all in one script. Well, now if you think about that, that would take lots of mouse clicks. For Kentucky, 120 counties, and to get the county files out and then to clip the river files so you have only the rivers of each county and to name them properly and put them in the right geodatabase, that's going to take some effort. Well, the script I wrote for it does it in 23 lines of code. Now, I did not run it on Kentucky yet. I ran it on Indiana, which has only 92 counties instead of 120. And it took me about 45 minutes for it to run. It created over 590 files for me in that time period. So if you think about how long it would take to create something like that, again, make you an automator of a task, not make you a programmer is what we're after. Okay, I know a lot of you looking at the names. It's nice to see names that I've worked with over the years. And some of you have probably even been in my Python workshops at the Southwest campus. But I'm Vince DiNoto. I'm the director of the National Geospatial Technology Center of Excellence, which is located at Jefferson Community and Technical College on the Southwest campus. And as that being that director of that national center, our job is to basically to provide curriculum and standards for the country. And hopefully we do a fairly decent job on that. One of the highlights that we do each year is our GeoEd conference. So I'm going to put in the chat window 2 hyperlinks for you that weren't unfortunately on the document I sent around. I just forgot to put them on it. So the first hyperlink takes you to the GeoTech Center, its webpage, and the information that we keep on its webpage. And the second one is the registration for the GeoEd 21 conference. We've got about 150 people registered at this moment. It will be virtual. It will be the beginning of June 8, 9, and 10. There will be a pre-conference day on the 7th and a post-conference day on the 10th of June. So hopefully you can join us. And it is extremely expensive. It is free. As I normally tell people, if you pay your taxes, you're welcome to come to the conference, but there is no charges. Okay. And what I am going to demonstrate are parts of what we call our model course. We're in the process of rewriting this course, and I'll talk a little bit about that in a moment. You should have, if you got this document, you should have gotten a hyperlink to where the course sits, but I'm going to go and post that also in the chat just so that you have it. So we're going to be using that as our guide. And the model course is composed that another instructor somewhere else in the country could pick this up and hopefully would have all the information they need to be able to teach the class. The GeoTech Center has 10 model courses, 11 model courses, but we have one on crime mapping that's being revised right now. It has 11 model courses and they're completely free to use. And the newest one is the rewrite of the Python class from scratch. As you noticed in its name, it is a story map is the composition of the entire model course. And I'll show that in just a moment. And I should give you one little disclaimer is it's still a work in progress. And I'll explain a little bit about that in just a moment, but it is a work in progress, our model course right now. So it's not fully complete. So I'm going to share my screen now, hopefully. And what you're seeing now is, hopefully everyone's seeing now, is the landing page for this model course. Jessica, is that coming out? Yes, I see your thumbs up. So hopefully everybody's able to see this. And this is what my notes are going to reference, is this model course. And I'll talk a little bit about that. And I'm sorry, that's not what I meant to click. So like if you look on the handout that I passed around via email, it will say things like slide 2 of module 1. So here are the 9 modules in the model course. We have an intro to Python, getting started, Python and GIS, basically, loops and decisions, Python labeling and calculating fields, inputting data, the Python window in ArcGIS Pro, more Python, more commands, and then finally the one on notebooks, which is an interesting one. And I became a firm believer in using notebooks, but they have a lot of ability. So if you have this site up, we're going to basically start in module 1. We're just going to click get started, which takes us to module 1. And so in module 1, what you're seeing here is using 64-bit version of Python. So let me go back just a step. This is why this is a rewrite, is because we went from 32-bit Python to 64-bit Python. In general, when you have code from an older version and you move into a newer version, in general, that code works. Not the case in Python. There's a lot of changes that were made by Esri and between ArcGIS Pro and ArcGIS Desktop. Desktop is a 32-bit program, Pro is a 64-bit program. And also there is a different version number of Python. So basically, so we all are working on a level playing field. What we're talking about is Python for ArcGIS Pro. Now it can be used other places and for other purposes other than mapping, but we're going to be looking at just from mapping. So 64-bit version of Python is what we're going to be looking at. And we're going to specifically look at it in ArcGIS Pro. We're not going to use it in ArcGIS Desktop. That's the transition we're making as we see the industry transitioning from desktop versions to pro versions of mapping software. We're making that same transition, and it has been a complete rewrite. What I thought was going to take me maybe 40 hours to do, we're well into the 300-hour range now on what we have done and things. So that's where we're going to start with. So what's in this whole class? So I'm going to go to slide 2. This is a story map. And I should have noted, we're funded by the National Science Foundation. I need to always note that that's who pays our bills, basically. But as you see here, this is what the course content is over on the left-hand side. And again, everything that we're doing is going to be done in Pro. Nothing's going to be done in desktop. Some of it will be done outside of Pro, but it will all be done in a 64-bit version. I'm going to just continue to scroll down to slide 4. How do I know what slide I'm on? Down here in the bottom left-hand corner, it shows my slide number. So I'm on slide 4. Again, this is a story map. And there is a significant difference between 64-bit editors and 32-bit editors. I had used PyWin as my editor when I was doing 32-bit. I could not find a PyWin version in 64-bit. It may be there, but I was not able to locate it. So I switched my editor to being PyScripter. PyScripter is a good, solid editor. And it is the editor that we're going to be using when we're outside of ArcGIS Pro. Some of what we'll show and talk about will be done inside of Pro, and some of it will be done external to Pro. These are referred to as IDEs, as you can see what an IDE stands for. And so this is a smart text editor, basically. It knows Python, so it knows the command structure, and you can also run your code within the editor. So I'm completely outside of ArcGIS Pro when I'm running some of my code. And most everything that we're going to show you can be done in multiple different ways. It can be done within ArcGIS Pro. It can be done separately in an IDE. So what you're doing and how you're doing it, there's many different ways that you can do it. And so these can go back and forth. So when we are doing things in PyScripter, we're completely outside of ArcGIS Pro. We're calling the library of ArcGIS Pro, but we're working completely outside of the normal software package. And that takes a little bit of time for me, at least, to get my head around that we're working outside of the software, but yet still doing geoprocessing commands and things. So that's important to understand. Python can also be used in QGIS, and there is an editor for that. We're not going to talk about QGIS per se in this discussion, but the Python components, not the mapping libraries, but the Python components are the same, no matter if you're using it for QGIS or if you're using it for ArcGIS Pro. The actual command, like to do a clip or something like that, may take a different format because it's a different mapping library that you're using. Anytime you do programming, there's lots of stuff that we have to concern ourselves with logic and formatting. And probably the most basic one is a variable. there are two basic types of variables. There are text variables, which means these are words, letters in numbers, but not numbers from a mathematical standpoint, numbers from a text standpoint. And there is then numbers, and numbers can have mathematical operations done against them. So we got to keep that straight, that when we're looking at things, that we have text and we have numbers. Now there'll be something called a list that we'll talk about in a few minutes, but we have two basic types of variables, and realize that number variables, we can do mathematics against it. Now, when I learned my initial programming many years ago, we had like 6 or 8 characters that the names could be. Now we can write our variable name as long as we want it to be. So make the variable names always descriptive. That's probably the biggest thing that I had to learn, was making my variable names always descriptive. So here is a look at my IDE. It comes in as a default 2.7, which it says 64-bit, but that's not a 64-bit operation. That is actually a 32-bit operation. And you have to go in and change it to a 3.x version. And it's not hard to make the change. And we tell you, go step by step through here how to make the change. But the reason it came in as a default at 2.7, I have ArcGIS Desktop on my computer, and I also have ArcGIS Pro on my computer. If I had only Pro on my computer, it would automatically bring it in the 3x family and not in the 2x family. And so we step you through step by step how to make these changes. And eventually, as you can see here, we brought it in and it now shows it as a 3.6 version instead of the 2.7 version. And that's the version that we want to work with for ArcGIS Pro. All right, I think that's all I'm going to show on this module. So let me go over to the chat and see if there's some questions. Or Jessica, you can tell me if there's some questions. All right. Trying to get over there.
Hey, Vince, it's Anne Marie. There's no question. Oh,
okay.
Looks like there's no questions, or there weren't until Ryan Kim. Is there a way to confirm if a script is 32-bit versus 64-bit?
I'll tell you the easiest way is to look for the print statement. In fact, this is just right here coming up on my screen. If the print statement has parentheses around it, it's 64-bit code. If you find a print statement and there's no parentheses around it, it's 32-bit code. That's probably the quickest and easiest way that I know to determine that. Good question. All right, so I'm going to jump to module 2. I'm in a collection of all my story maps. Each of these lessons is a separate story map. So we're going to jump to module 2, so getting started with Python. And the first slide I want to talk a little bit about is slide 3, which is the print command. Okay. And what I want to show one thing here on the print command, so you can see I'm in, let me step back here. I'm in immediate mode right now. I'm not in a programming mode. If you see these 3 greater than signs, that tells you that you're in immediate mode. So when you're in immediate mode, if I do one line of code, that one line of code then shows the results immediately. I wish my age was 59, it's not. So you can see these lines of code. But down here near the bottom, I say print. My name is a variable that's not showing up on the screen. my name is, here's my variable, and my age is, and to make my age, which was a number, look like a text file or a string, I had to put the str command in front of it. Also notice things that are inside quotations are not variables. So my name here is a variable. My name is inside the single quotes, or it could be double quotes, it doesn't really matter, is a string of text to be included in my output. So in my output, it's showing my name is, there should have been a space there in after the is, my name is showing there, and then my age is, and showing the results of the variable. So notice though, everything has parentheses. If you were working in the 32-bit, you would not have any parentheses there. So I'm going to move down to slide 5 here. I should note here, there are assignments in this also, since this is a model course, and you're welcome to do the assignments. There's also videos included. This is a video over on the right-hand side. And I want to talk just a moment about a list variable, because it's probably one of the most important components within any Python script that you write. And to make something a list variable, you put square brackets around it. So notice my naming. I created a new variable. It's called list address. The word list does not make it a list variable. The square brackets makes it a list variable. And then we have a bunch of addresses placed in it. Notice each address has a quotation around it. These are single quotes. It could have been double quotes. It does not really matter. And so I have created a list of similar items. That's going to be very important when we do our looping statements, that we understand how those work. Notice the pound signs in a sort of a gray color. Those are all comments. So all this is comments that have these pound signs at the beginning of the line. So comments are, I encourage people to use comments. I'm not great on using comments myself because I want always to get my result quicker and don't really take the time to always comment my stuff. It's just like metadata. If you put good metadata in your files, you can use them better later than trying to figure it out on your own. So this is another list variable. Again, my convention is that I put list as part of the name in general, then I can put a capital letter. So this is list grades. So let's say this was a student's grades. And this is a numeric list variable, where the first one was a text list variable. Again, you cannot mix the types. So this 1000 in Community College Drive is actually, that 1000 is not a number. It is text. Down here, these are actual numbers. Notice there's no single quotations around them. But again, the square brackets makes it a list variable. So you can have a numerical list, you can have a text list, but, and again, you have those two major types, text and numeric. So want to bring that up. So that's everything I want to show you in my second module. And now we're getting closer to actually really writing Python. So I'm going to jump to the third module. So this top line here is the different modules. And then these are the different parts of an individual module. So we're going to go to Python and geospatial technology. And I am going to go to slide 2 and talk about programming mode. And we still are missing a slide there. When I'm in programming mode, each line of code is not executed until all the code has been written and you tell it to execute the code. So if I go to PyScripter here, in PyScripter, you can see here that we have a block of code here, and we'll explain some of this code in just a moment. But here's my code showing up there. It's probably a little bit small for you to see on your monitor, but here's my code showing up there. Until I tell it to run, this is just a bunch of text. I can jump down here, and here's another block of code. And again, it does not execute until I tell it to run. The run button is right up here. The green pointy arrow to the right is the run button. At that point, what you'll have happen when you run a block of code, it will give you any errors that you have sort of in the bottom of this window, and it will give you any results down here. This is also our immediate mode area, but if you notice the 3 greater than signs, that's our immediate mode area. So when we execute some code, we see the results, and this is inside PyScripter. You can change the background color. I just tend to keep it in a black color. It helps me know where I'm at, but I keep ArcGIS Pro in white. Therefore, if I have code that is, excuse me, if I have code that is wrote in my IDE, it is done on the black screen. It's just a way of keeping things straight for me. All right. All right. So let me go to this page here. And ArcPi is the library of all the different functions that you may use. So if you use clip and merge and all those type of commands, that's all stored in a library. And that library, for the sake of code, is going to be referred to as ArcPi. And here's one of the things you got to be real careful of, and it even shows up a little bit right there. There are no capital letters in ArcPi. If you put a capital letter into ArcPi, it's going to bomb on you. So you'll see a lot of people write it as capital A, RC, capital P, lowercase y. And if you put it into your code in that format, it will not work. It will give you errors. So please be aware it's all lowercase letters when we talk about ArcPi. We also have to use ArcPi as part of a tool. So this line here, hopefully you can see it, I'll highlight it for you, is showing you what the structure is. And so you have ArcPi dot the tool name, and we'll talk about that in just a moment. What toolbox is that tool in, what I call location, with an underscore there, and then you have the different properties. So let's take, for example, the one that I've gotten showing here down at the bottom of the screen, ArcPi dot union. Where's the union tool at? It's in the analysis toolbox. And then what kind of parameters do you need to give it? You give it an input feature, that's a pathway to your file. You give it an output feature, where is the information going to be stored? Then you have other things like join attributes and tolerances and gaps and things like that. But the first 3 parameters are the only ones that are required to run the union. It's the same thing that you do if you're doing it just in ArcGIS Pro. You have to give it an input, you have to give it an output, and you have to tell it what join attributes to use. There is no difference. So the tools look the same. The biggest thing is always to know what toolbox the tool's in. Well, these are smart editors, and if you've loaded ArcPi properly, it will give you helpful hints as you start typing union where it's located. So you don't have to remember everything. You just have to remember some things. So let me go down here to buffer, and let's look at a script. So here is a script that will do a buffer. And hopefully everybody is okay with what a buffer command does. So we start off with 2, 4, 5 lines, and these 5 lines are comments, nothing more. They have no structure to what the script will do. The next command is import ArcPi. It's always one of those commands that you put real close to the top. So you're going to import ArcPi. And then you're going to create a feature you're going to create where is the input data at. So you import ArcPi, then you tell it where is your data going to be at. So I made a variable called feature input. The R is used because of the direction of the slashes. It is outside of the quotation marks, so make sure you put the R in there. And then where is my data? Where my data is in the KY geodatabase. Where is that geodatabase? It's sitting at users, GIS 255, GIS data. That's the pathway to where my geodatabase is. And the file that I want to look at in that geodatabase is called college. So here's where my input data is coming from. After I do my buffer, where do I want to send the output? Where do I want the buffer to go? So the feature output file is going to be, again, my R, quotation marks. C is the drive I'm using. It's again in the user folder under GIS 255 under GIS data. It's in the Kentucky geodatabase. So I'm putting the data back in the same location as where this data came from. So the input data and the output data are going to be in the same geodatabase. And I called it buffer1. That file does not exist right now in the KY geodatabase, but I called it buffer1. And then the last thing you have to tell your buffer command is what is going to be the radius. So I've created a variable called radius. Notice it's inside quotation marks and it's 25 miles. You've got to format this properly for it to work, but you do have to put here what the units are. If I could have put meters in, it would interpret in meters different than miles. And then finally, I come to the command line. So notice the structure. ArcPi.buffer _ it's in the analysis toolbox, parenthesis, input. Well, this is the variable name that I created, feature input. The output file where the buffer is going to be stored at, and I created a variable called feature output. And then finally, the variable I created called radius, which is a text saying what is going to be the radius used. At this point, I would press the run command. When I press the run command, then it should execute this command if I have no typographical errors. Biggest problem I find is typographical errors, both when I've taught this in-person workshop and also my own working in Python, is I make typos. And so it runs this command, and I'm out. Now I'm in my IDE, so I'm outside of ArcGIS Pro. I don't know what it looks like. It ran the command, but to know what it looks like, I have to come back and bring that file, buffer1, into ArcGIS Pro and look at it. And when I look at it, then I can see if it did it correctly. Because again, I'm doing this all right at this moment outside of ArcGIS Pro. I am doing it in an IDE. So let me stop there for just a moment and see what kind of questions people might have. Any questions?
Vince, I'm not seeing any new questions.
I don't see any hands raised.
Okay, just want to make sure that we're keeping everybody together. I appreciate you monitoring that for me. All right. Well, notice how long this string of information is, my storage location. And notice my output storage location is all the same until we get to the name of the file. These two are exactly the same strings of storage until we get to the name of the file. So there's a nice thing that I never use in Pro or in desktop, either one, but there's an environment command. And so I'm going to scroll down here. Oh, there's the results, by the way. Took about 2 seconds to run in the IDE. There's also videos, as I noted before, that you can watch. So we have this command called an environment command. And so what it does, and we'll look at the structure in a little bit more detail in just a second. What it does is it says, all my information, unless I specify the full pathway, is going to come from my geodatabase. So this is the same geodatabase I just used in the previous example. But what we've got here now coming is all my information coming out of this geodatabase, unless the full pathway is specified. So the first command I normally do is import ArcPi. So assume that I've already done that above here. The next command generally that I do is I set the environment up. So we have to put a command, and it needs to be in this format, from ArcPi import env. Once this line has been put in, I can then set my workspace. And usually it's just a single line like I'm showing here, env dot the workspace equals, notice my R again, and then we have our double quotes at the beginning and at the end. And so therefore, if I do something like this, I don't have to give those lengthy pathways like I showed here. Now I only have to say the input feature is college and the output feature is buffer 1, because I've set the pathway using the environment command. So it makes for a much simpler set of code and also much quicker inputting of the code, that you only have to type something like this once. So in the next example, I'll show you how that works. So the next example I'm going to show you is the clip function. So again, anything with a pound sign in front of it is going to be comments. So let's just go step by step through here. We import ArcPi. We next import the environment. Then we set the environment. Then I'm coming in here and saying county equals Trimble. So I have named a variable Trimble. I've named a variable county, and what is inside that variable is the word Trimble. Since it is text, this is a text variable. And then I'm going to do the clip command 3 times. And this one is a little bit more complicated. So we got ArcPi dot clip. Clip is in the analysis toolbox, parenthesis. We're doing 3 variables here. The first variable is where's the data coming from? The data is coming from Kentucky Rivers, but it doesn't have a full length path here because Kentucky Rivers is sitting in my KY1 geodatabase. The next thing I do is tell it what is going to be the clipping file. So what is that polygon boundary file going to be? And for this case, it's a file called KY_Trimble. We could have done this a different way, but this is the method I chose to use here. Where is it located? It's also located in the KY1 geodatabase because I have given no pathway to it. And then the third feature of a clip, after you give it the input, the boundary, is where's the output going to go? So I've used my variable county, which is Trimble, and then I've added that on to the variable rivers. So this is going to be Trimble _ rivers when it's done. Where is it going to be saved? It's going to be saved back to the KY1 geodatabase. Why am I saving it there? This is all Kentucky data, so I'm saving it back to that same database. So then I repeated it for Kentucky roads, and then I repeated it for landmarks. All files are contained in my KY1 geodatabase. All the outputs are descriptive, and they are also in my KY1 geodatabase, and the same clipping boundary was used for each one. So you can see how this works. So again, a simple single command. We could have made it even simpler by using my variable name in here. If I changed from Trimble here to, let's say, Jefferson, and reran this and had made my changes here, I could rerun the whole script, and all I had to do was change the name of the county. So you can see how this starts to become powerful, but this is still in its very simplistic state, because I could have done some type of a looping command here. And by doing some type of a looping command, it would have even reduced the number of lines of code for me. All right. Any questions at this stage?
You have a couple
Okay.
advents.
All right, let's see. From Melissa, can the workspace point to an enterprise geodatabase instead of a file geodatabase? It can. It's a little bit trickier because you may have some permission issues and things like that. There are ways to do it. I have sort of gone away from doing enterprise geodatabases, but it can be done setting your environment. But again, if you have permission issues that you have to give to your SQL server, let's say, then that's going to be some things that you have to work out on how that actually structures and things. You'll find in most of the literature that Esri produces right now, they're doing most things in a file geodatabase or something like ArcGIS Online. But even with ArcGIS Online, you have to make sure you get the permissions all right and get the tokens all right, passing back and forth between them, or else you have problems. So hopefully that answered your question there. Can you reset within the script? Okay, can you reset within the script, then set the environment back, switch between paths using environment reset each time? I think you can, but I've not tried that. It's a good question. What I typically will end up doing is I set my pathway like you're seeing here. And then let's say, for example, my boundary file wasn't in this geodatabase. Then I will create a variable and have my complete pathway in my variable instead of trying to do multiple environmental workspaces. I will only set up one generally, and then all these other files would have direct pathways is the way that I typically do it. Maybe not the most efficient, but the simplest from a code standpoint. Okay, from Charles, interested in the space in the folder name that didn't trip it up. I typically try to avoid spaces and names. If it had been in the name of the file, it would have tripped it up. So if you notice here, these things that are stored in the geodatabase all have underscores with them. So if it would have been inside the geodatabase, it would have definitely tripped it up. But since it's part of the pathway to the data, it doesn't seem to trip it up. But I'm trying to change all my pathways to putting underscores in it just to be on the safe side. But I've done this numerous times and it's not tripped it up by having that space there. But that doesn't, I'm not sure if that answers your question, Charles, or if it was just a comment there.
I think that's it.
Okay. All right. We'll keep going unless there's some other questions. Okay, we're going to move to module 4, which is loops and decision tools. There are different types of loops that we're going to talk about. Let me make sure I get to the right slide here. Okay, yeah, we're going to start here. So I'm going to actually take a picture of this screen so I can draw on it. Hopefully this works. Okay. So if we look at this, we have over on the right-hand side, we have data coming in. And we ask, and we're going to look at the code to this in just a moment. And this is about students. So we ask a question, is does the student have less than 12 credit hours? If the student has less than 12 credit hours, then this is true. And we pass into here, and that we're going to name this, give the student a type. So the student type is beginning freshman. So that's saved as a variable, and we print the student type. And we're done. So we just pass straight through. If the student has more than 12 credit hours, we want to see what type of student they still are. So we go out of the branch this way. And by going out of the branch that way, what we're looking at then is less than 30. But really, it's not just less than 30. It's more, it's 12 or more and less than 30. Because we've already decided if they were 12 or less than 12, they went down the right-hand side of this pathway. If they were greater than 12 or greater, but then less than 30, if that's true, we say they're a freshman. And that would be the student type. They would drop out and they would come back over here and we'd print their student type and we'd be done with that student. But if this is false, we come over here. So if it's false, that means they have 30 or more credit hours, and we check and see if they have 45. So we're looking at 44 to 30 credit hours. If that is true, we drop down here, say they're a second year student, come over and print it out. If all those things are false, they're not less than 12, not less than 30, not less than 45. That means they are 45 or more. We come over here, we change the student type to nearing graduation, and we come back and print it out. So there's a nice little flow chart of an exercise, but now what we want to look at is how do you write the code to do that? And now this is completely non-geospatial, but once we get a feel for how to write the code once, it can be used for whatever task we have at hand. So I'm going to close that if I can. Yeah. And I'm going to scroll down and let's look at the code. And I'm going to also take a screenshot of this one. And so we set up manually what the value for the student is. We set it up as 6 hours. And then we use an if statement. And the if statement says hours less than 12. We're not worrying if it's true or false yet. Just look into structure. Notice at the end, we put a colon at the end. This is critical to make this work. So if hours is less than 12, if it's true, it's going to do what is indented. If it is false, it's going to go to this else if statement. That stands for else if. If that's the case, if it was false, it's going to drop down here. If it's true, it's going to put what's in the indent. If it's false, it's going to go to the next else if statement. And if that's false, it's going to finally go to the else statement and say, we've tried all the options. It's got to be this. And then at the end, we get to the print variables. So if we look at our initial thoughts, 6 hours is less than 12. So we change the student type to beginning freshman, and then we jump down to the print statement, following the flow chart that we just looked at. So here's how an else if statement works. We can also have nested if statements, but this is how we work with if statements. The keys are the indentation, and the indentation are controlled by the double colon. If you work in an IDE, generally it automatically will indent those spaces in. If you're working like in just a text editor like WordPad to do this, and you can write your Python script in WordPad or something like that. You need to indent it. Do not use the tab key, use the space bar, and make sure you know exactly how many spaces that you're showing, because if you show a different number of spaces, it's not going to work. So let me close that window, go back here. And so that's the if, else statement combination. Do we have any questions on that?
I don't see any.
Okay. I'm going to talk just a moment about the while statement. It works very similar. So we set a counter up. So while counter less than or equal, notice the formatting here, 8. And then we got our our colons sitting here. So we're going to say, look at the counter. The counter starts off being 1. I'm sorry, my phone is ringing in the background. I'm going to ignore it. Hopefully it'll quit ringing in just a moment. All right, counter equals 1, while the counter is less than or equal to 8. So the counter is 1 the first time through. It does what's in the print statement. It's going to print out counter equals, and it's going to put a space in there. It's going to add it to make the counter, which is a number, into a string. So it prints it. So it's going to print what the value of the counter is. It's then going to come in and increment the counter. Notice the methodology used for incrementing the counter. It's then going to go back up here to the while statement again, and it's going to check, is the counter 8? Well, we incremented the counter by 1. No, it's 2 right now. It's going to do the print statement again, increment the counter, make it 3, go back up to the while statement. Keep doing this. The counter will become 8. 8 is equal to 8. So we do the print statement one more time, increment the counter to 9. Is 9 less than 8? No, 9 is not less than 8. It then drops out of all the indented material and goes to the print statement. The loop has been successfully run. So that's a very simple loop that we do. So if we have the same repetitive process that we need to do, a while statement might be the way to do it. Typically, I have not used a while statement in very much of what I have wrote. I will typically use a for statement, and we'll look at that in just a moment. But typically a for statement does this job and does a better method on it than the while statement, for what I do at least. Here's the flow chart from what we just talked about. You define the counter, we check the counter. Is it true? Go this pathway. Once the counter gets to be bigger than the criteria, we go down and continue the process. Here's the output of that little while statement I just talked about. Counter equals, that was text that we put in. This is our variable counter, and we can see it going down and incrementing by 1 each time. So just a quick test to make sure it worked properly. The for statement is something that I use probably the most of any statement, any looping statement. And there are different ways to use it. So we're going to come in here and look at a way of using it. So we're going to create a variable. We called this variable name KCTCS. And what I'm putting in here, notice the square brackets, the name of all 16 KCTCS colleges. So you cannot see all 16 because I truncated it when I did my clip, but the name of all 16 colleges. So then we have a statement that looks like this. For a new variable that I've created, college, that's my variable name. For college in name KCTCS, colon. So the first time in the variable college will be Jefferson. It'll come in here and print the word Jefferson. It will come back to the top of the for statement. It will change the variable college to be Elizabethtown, because that's the next variable in the list. So the variable is now Elizabethtown. It'll print Elizabethtown. It'll go back and check, are there still things I've not used in the list? Well, Maysville would be next in my list. It'll print Maysville, and it'll keep doing this till it prints all 16 college names. And then it'll drop to the second print statement here and say done with the list. So all it's doing is reading everything that is in this variable. With that being said, here's the output. You can see everything that's in there having been printed. And then at the end, done with the list. You can also nest variables and our nest loops, excuse me. So here's my name, KCTCS. I also have a new variable I've created called college semester, and it's just got 3 members, fall, spring, and summer. So the first for statement is just what we went through, and it prints the name of the college. But then we come to an internal loop that looks at the first value in the college semester, which would be fall. It prints the semester. It goes back to the for statement and says, is there any more new items that I've not used? Well, spring's not been used. It goes back through this loop again. Then it'll come back and says, is there any more semesters? Yes, summer's not been used. It does that. It'll come back and say, have I exhausted the list? Yes, I've exhausted the list. So I then go back up to the for statement, and we change the college name to Elizabethtown, and we go back and go fall, spring, summer. When we get all done, this is done, ran 48 times, 16 colleges, 3 semesters, 48 times these loops ran. It'll finally print done with list. And if we look at that, there you can see a part of the list. I probably use nested for loops more than anything else in the Python scripts that I have wrote. All right. Do we have any comments or questions? It looks like we may have one here. Okay, Cynthia, I'm assuming if you're using numbers in the list, the college ID instead of the college ID would be set as an integer or a real number with formatting. Basically, if it will automatically format itself unless you want to specify the formatting, Cynthia. So if I just put in my list variable, 1, 2, 3, 4, 5, it's going to assume that they're integers because none of them have a decimal place in it. If you put in your list 1.01, 1.02, and so on, then it will know that it has, 2 decimal places and things like that. So it pretty much does it by default. I've not ever had to specify any numerical format in any of the stuff that I've worked with. And maybe I'm missing something there because I maybe just haven't worked with it or not. Is there any other questions from anybody?
I don't see any.
All righty. Thank you, Andrew. All right. Well, we're about halfway through, a little bit past halfway point. Let's take 5 minutes. Just
Hey,
so
Vince, somebody just asked a question.
I'm sorry.
Ryan Kim just
Oh,
asked.
yes. Is it possible to code using an ArcPi module without having ArcMap or ArcGIS installed? No. The ArcPi module is part of your package. So you could write all the code you want on a computer. You wouldn't get any hints coming up as you're writing the code in your IDE and things. So you could write all your code. You just couldn't execute your code. You could save your code and then bring it to a machine that has ArcGIS on it. I'm sorry, GIS Pro on it and then run it. But without the Esri product there, it's not going to run. Now, again, as I noted earlier, you can write Python code for QGIS. And obviously QGIS is a free package. And so you could write code for something like QGIS. Okay, let's come back at 2:40 and we will continue with where we're at. All right, let's start back if it's okay. All right, so I have moved to module, let's see, 5, just to make sure I'm thinking right. And what we're now going to do is work inside ArcGIS Pro for a couple modules that we're going to go through and things. So what we're going to do is, well, let me just open up ArcGIS Pro. So if I'm here in ArcGIS Pro and I click on the labeling tab and I come over here and I choose a field and I've got labeling turned on right now. If I come over here and click on the expression button next to the field that I'm looking at, it's going to open up a little window, and I'm going to just expand this window a little bit so we can see it better. And we need to choose the language. Now, for years, as I did labeling before I got into using Python for stuff, I just sort of ignored this window even existed. But the first thing we got to do is choose the right language. So we're going to choose Python. You got to make sure that you click on the advanced button here, and notice it will write some script for us as we do this. Notice this is all the fields that we have. But since we're in the labeling tab, this is not going to change anything inside of our fields. It's not going to change the name of, in this case, these are cemeteries. It's not going to change the name of the cemeteries in Rush County, Indiana. It's going to change how they are displayed. So in this expression window, and we're going to jump back out of this in just a moment, but in this expression window is where you're going to write your Python script. So the example that I've used for this is I have a file called Kentucky Railroads or Kentucky Rail. And here are the different fields. So that's the same window I was just looking at. Here are the different fields that we have here. And what I'm going to look at is this field called RR owner, but that's who owns the tracks. That's the field that I'm concerned with. I'm sorry. So I'm going to select RR owner. It automatically fills this in for me by clicking that advanced button there. But then after that, let's look at the code because it's a good use of our if else if statements. So RR owner, RR is a variable that I created, which equals the owner field. And notice it's in square brackets. So therefore this is a list. So this is all the different owners that are in that field. So I say if RR equals and only equals CN. What's CN stand for? Canadian National. So if it equals CN, which is what's inside this table, I had to do some inspection inside this table to know what's going on there. And I put my colon at the end of my if statement. So it automatically, well, this actually I had to manually indent because we're inside ArcGIS. I'm sorry, yeah, ArcGIS Pro. I had to manually indent it. I'm going to change what appears on the screen. So this return statement is sort of like a print statement. That is what appears on my screen. I'm going to change it to being Canadian National. So somebody looking at my map would know this is a Canadian National map where they might not know what CN stands for. But if it's not CN, then it drops down to my if statement. And then we check, is railroads equal to PAL? In my colon I put here. It returns, if it is true, it returns Paducah and Louisville. That vertical line is just where my cursor was when I took the screenshot. So don't worry about that. It returns Paducah and Louisville onto the map. It doesn't do anything else with it. It just sends it to the map. It doesn't change anything in my attribute table. So if that wouldn't have been true, it drops down to the else. Now this is very simple. It only has two choices up there. and it returns unknown. Obviously, it's not unknown, but we only classified 2 of the railroads, and then it returns on what we are doing. So we drop out of this little loop here. So you can see how the if else statement might work. And so what does it do? It creates a map that looks like this. And if you look very carefully, you'll see right here is Paducah and Louisville. We didn't do anything about making the map fancy. There's Paducah and Louisville again. We didn't try to make it nice and fancy on our labeling. Over here in far western Kentucky is the Canadian National. That's I think the only place it's labeled in there. And notice all these railroads that are labeled unknown, which again, there are values in the table for these railroads, but we only classified 2 railroads. But again, we did not change anything in the attribute table. All we did was changed how it was going to appear. But let's take this just a little bit farther. So here we go back to our code. We modified our code a little bit. So if it's CN, if it's Canadian National, return. I notice my quotes here, double quotes and things, and I use some single quotes. I'm going to set the color for Canadian National to be red. So notice my diamond-shaped brackets here. I'm using a little bit of code here. So CLR stands for color. I'm going to tell it red equals 255. So our color range can be between 0 and 255. And then I close my diamond-shaped bracket. I open a new diamond-shaped bracket. FNT stands for font. Make the font size 15 point. Notice my single quotes there. Close the diamond bracket. We're going to add that to Canadian National like what we had before. Before it just said return Canadian National. So now we're going to add the color red to Canadian National and the font size 15. Notice then we use our backslash like you do in HTML code. Our backslash in last thing called is first thing closed. Next thing called, next thing closed. So these backslashes. And then we did sort of the same type of thing with PAL. If it's PAL, make it bold, BOL stands for bold. Color, make it green, but don't make it fully saturated at 255, but make it somewhat less saturated at 200. We put the name Paducah and Louisville. We close color, we close bold. And then we hit our else. So we're going to still label everything else in black, unknown. And what do we get as a result? Here we get our result. And you can see that Paducah is bold, and you can see the Canadian National is taller. You can see Canadian National is red, and Paducah and Louisville is green. So again, how to really enhance your labeling with very, very little code. Inside, you have to do this inside of ArcGIS Pro. I could have wrote my script. I couldn't have ran my script, but I could have wrote my script in my IDE and then copied and pasted in here. But my script was pretty small. And then for my assignment for my students, they have to classify more of the railroads. So they have to do a bunch more ifs and changing colors and things like that. So it works both on the cyan magenta way of doing colors. It also works on the RGB way of doing colors. And you can mix colors. So you don't have to just be pure green, pure red. You can mix red and green to get whatever color there, or blue and red to get purple, or whatever you want as a color. So you can have multiple colors inside your statements here instead of just a single color. So I'm inside of ArcGIS Pro. I'm in the labeling tab. And what I've done inside the labeling tab now is I have created unique labeling depending upon what is the value in the field. So let me stop for a second and see what we have in the chat window. Can you use symbols instead of text. Not sure what kind of symbols are you talking about, Cynthia? Okay. If it's a GIF, I don't know. Good question. I don't know. I've never tried it, never even thought about it, to be very honest. So can't give you a good answer for that one. I would think you could, but I've not tried it. So I can't give much help on that one. Sorry. Okay. Just for sake of time at this moment, I'm going to, the next one that we were going to talk a little bit about was, there's another place in ArcGIS Pro that you can write script, and that is in calculated fields. So for example, if we want to change the appearance of how something comes out. So if I have, let's say, do you offer GIS classes? Do you offer certificates? Do you offer degrees? And those are all yes, no. I can create a new field in the field calculator using Python. You can do this manually also. And then I can say, if this is true, and this is true, and this is true, then put in this field the following information, that they offer degrees, certificates, and classes. If A is true and B is true, but C is not true, put that they offer certificates and classes. So you can do those type of things inside the field calculator using Python and looping functions. Also, inside of this lesson, we show you how to do a couple things with the field calculator, but for the sake of time, I want to make sure I can get into a little bit into notebooks. So I'm going to skip over that right now and move forward if that's okay with everybody. All right, so we're going to jump to the next lesson, inputting data. I'm going to drop down to a new command. I'm only going to just mention this a little bit to you. And so everything that I've talked about up to this point has been that I have manually put the name of the file into the script I'm writing. So like when I did the Trimble County, I put the name Trimble in there. And I told you if I wanted to use a different county, all I had to do is go change that one place in the script, which was true. But it'd be nice to be more like a regular tool that you use, like clipping tool or merging tool, that what you do is you go click on a file and bring that into your script and use that. Well, there's this command called get parameter as text. And it has a little wizard that runs with it. And that little wizard gives you the ability. So here's my script. I'll come back to that in just a moment. But the little wizard gives you the ability to name different things, what your label is going to be, and so on and so forth. And we can eventually come in here and define what kind of input we're going to have. Is it going to be text? Is it coming out of a geodatabase, or is it coming out of a file folder? Those type of things. So you can write your script, and each of those boxes for input, you use a command called get parameter as text. So the first one is 0. So the first box is going to correspond to this input feature. The second one's going to correspond with a number 1 to this output feature. And so if I wanted to take, for example, a file and save it in a geodatabase that is a shapefile right now, I could define input. When I run this tool inside of ArcGIS Pro, it's going to want to know where the input file is. I go find the input file that's loaded on my map, for example. Then it wants to know where you're going to put the output file. So you tell it where to put the output file. And then you use this command called feature class to geodatabase conversion. the input file and the output file. But now what I have done is I've given you the ability inside ArcGIS to build your own tool. Now you got to be a little careful. We're not building something that's a new tool. We're actually just using tools that exist. For example, if I wanted to clip out 5 counties out of the state of Kentucky, and then I wanted to merge those 5 counties together, and then I wanted to use that merge surface as a new clipping tool, it needs to know what 5 counties I want to start with. So I could use my tool that combines multiple tools together and do the process instead of going through, okay, I got to do that first clip, and then I got to do a merge manually, and then I got to come back and do that second clip of the river file, for example. I can write a tool that pulls other tools. We're not writing tools from scratch. What we're doing is combining tools together, or using set tools such as this feature class. You could go export your file to a geodatabase, but here we have a nice simple tool if you're moving a bunch of stuff around and things like that. So we have the ability inside of ArcGIS Pro to pull things in and then output them where we want to. And we can get this and not have to hard code the parameters, but instead click on things just like we're used to using other tools to do. And it's not hard to do, but it is an important feature to understand in things. Okay, I think we may have a question. Let's see.
I don't see one.
Yes, we don't really have a question. Yes, we are ending at 3:30. Yes. All right. Okay. Try to keep us together in things. All right. I want to show you one thing. I'm going to jump over here to ArcGIS Pro. I'm going to close this out just to get rid of it. Cancel that. All right. I'm going to go to my view menu, and I'm going to go to my Python window. And notice down here at the bottom of my screen, I'm going to expand this. I have a Python window. So if I said name equals Vince, and then I said print name, and it didn't like something I did there quickly. I didn't spell print correctly. Boy, print name. And there you go. So we actually have a Python window inside of ArcGIS Pro. Well, so why do we need an IDE at all? Well, this window works in immediate mode. Now you can make it work in programming mode sort of indirectly, but I can copy a big piece of script and I can drop it in here, and then I can execute it. So I can do some executing like that, but this is an immediate mode window of Python. So this is more line by line. As soon as you hit enter, that line of code is executed. It serves some purposes. There's reasons to be there. It's nice that you're inside ArcGIS Pro, so the results can be immediately seen on your map and things like that. But it also gives you some issues that you're working in immediate mode, and it's really kind of clunky when you're trying to do loops and things like that. So I want you to be aware that there is, as I said, a Python window. It's under the View tab, and it's called Python window here. So I'm just going to close that. So if I go back to my presentation, and I go to Python window in ArcGIS Pro, we've given you some examples here of different things that you can do. Some of these are things that we have done previously. And I'm just going to go talk a moment about them because, again, I want to make sure I get to some time for notebooks. So here's the buffer command done in the Python window. Each of these lines individually execute is just the same as was in my IDE. except I'm doing them line by line. Same output results. Here's the merge command. Again, line by line, we see the output results there. Spatial reference. So, you know, if you want to know the spatial reference of a map, you can go open the PRJ file up if it's a shape file and look at it. But here is a simple command that tells us what the spatial reference is. That would be something that might be worth doing inside of that Python window inside ArcGIS Pro. Get count. You want to know how many lines on your table. What do? You open up the attribute table and you go down to the last line and figure out how many lines there are there. Well, here's a single line command that tells you how many records you have. Or if you want to list what are the elements inside of a geodatabase, for example. If you want to know what's inside of a file folder, this is actually inside of a file folder. I should be correct there. So without having to go and open that file folder up, I used a command called list feature classes, put no information in there. So it's going to give me all the feature classes and told it to print feature, which is the variable name of listing the feature classes. And this is the output. I didn't have to go open that file folder to find out what was inside of it. Again, these type of commands, short little functions, are probably good to use with that immediate toolbar inside of ArcGIS Pro. We can do the same thing with list fields, just like listing feature classes. Instead, now we're looking at what are all the field names. How would I normally have done that? I would have opened ArcGIS. I would have opened the attribute table and I would have looked at the attribute table, all the names. Now I can also use these names for a purpose, but you know, you can see how this all functions and lays out here. But fairly quickly, I know all the field names and I have them actually written here. I could have saved them to a variable. Well, I did save them to a variable field name list. There's my variable. I could do something with that if I wanted to, instead of just printing it out. I made it into a loop. And the reason I made it into a loop, so each field name would be on its own separate line. Again, all this material is available to you, so I'm not trying to, I am trying to rush a little bit, but it is all available to you. So I am actually going to skip down to module 9, which is creating a Python script within a notebook. So since I haven't asked you a question for a while, and I'll get to the chat in just a moment, how many of you have ever opened a Python notebook inside ArcGIS Pro? If you just raise your hand, please. Okay, I'm seeing a few hands, not very many. And
Got some thumbs up down there too. So I think about 4 or 5.
right, okay, yeah. So I'm one of these people. Well, let me look at the chat first, please. I'm sorry.
I don't see anything in chat.
Yep, we're good.
Yep.
All right. So I was one of these people who saw notebooks, saw a very good presentation, but it looked like a black box to me. And I said, I don't want to learn notebooks. And so I went to some other presentations and everybody's using notebooks in it. And so finally I said, I guess I need to learn this stuff. And so about a month ago, I went to this really good workshop on notebooks, showing lots of little things on it. And all of a sudden I got hooked and I decided if I had time to rewrite this class, I might start with notebooks, because I had thought maybe it's over the heads of most students and things like that. Lots of things, but probably more than anything, I just did not know if I wanted to learn another new technology. So I'm going to go back to ArcGIS Pro, and I'm going to come in here and look at one of my notebooks. And I'll show you how I got here in just a moment. So I'm going to choose Notebook 2 tab. So let's look at this first box that I got here. It says import ArcPi. From ArcPi, import the environment. And then we set the environment. Okay, it's a geodatabase called Indiana Counties, or Indiana County. Notice the underscore there and things. And so then what do I want to do? Indiana Rush underscore IN underscore Rush underscore cemetery. That's my input file. My output file is going to be cemetery underscore buffer. Okay. And the radius of my buffer is going to be 1 mile. Now, why do I want a 1 mile radius buffer around a cemetery? I don't know. But I thought, okay, let's do something that's pretty quick and easy and see how it runs and things. So you can see the code. It's no different than if I wrote this code in an IDE. Now, if I wrote this code in my Pi scripter, it would give me a new file called cemetery buffer. Okay. I would have then had to open up ArcGIS Pro, and I would have had to then go in and look at it to see if it looked right. If it looked right, then I was good. If it didn't look right, then I'd have to go back and do it again. So for the sake of time, I'm not going to write this code again. I'm going to use what I've already written here. Notice next to run, there's this window called code. There's also markdown. So I could make this look a little bit like a web page. So I could add some features like that. I could add headings to it. So in theory, all my scripts for my entire semester could be stored in one notebook. Well, let's run this notebook and let's just see what happened. Well, no, let me wait. Let's not do that. Let me show you something else I learned sort of by accident. So here's my mapping window. I'm going to pull this window out. See this thing in the middle? I can tile this window wherever I want it to be. So I'm going to put it over on my left side. So notice this window can have all these tabs in it. This window has only one tab. I can change how much screen real estate I share. So there I am. So now I've got I'm over here looking at my code window in my notebook. And I have my map window over here open. Did not know you could tile like this till a couple weeks ago. I'm going to click run. Give it a few seconds. I got way too many things open on my desktop. Should not take this long. All right, there we go. It's getting there. Okay, and immediately I see the results. Or not immediately, it took 14 seconds. I see the results. It tells me where the output's been put. Well, that's where I expected it to go. And I've got all these 1 mile buffers around cemeteries in Rush County, Indiana. Just for geography's sake, this is in East Central Indiana is where Rush County is, just so that you know where I'm talking about. But all of a sudden, I ran this code and you can see the results. That's pretty cool in my mind. The code was the same code I would have put in the IDE. The only difference is I can see the results immediately. And I don't know if you were looking at my content window while this was running, but I actually saw that certain layers got locked. This layer got deleted and then got brought back in again because I had already had that open and I just unchecked it. But you can see it's a fully functional file. Plus this ability to tile my screen, I thought was just really, really good. So let's look at something, another case here. And so we're going to import ArcPi. Probably don't need that statement because I'm inside ArcGIS Pro. It knows where ArcPi is. My environment statement is the same geodatabase that I just used. I'm going to look at the same file that I just looked at, Indiana Rush Cemeteries. But this variable I've listed as field name list. So what are those fields inside of this Rush Cemetery file? I want them each on a separate line. And that's what my last two statements do, the loop. So field name is going to be a list variable. It's going to have all the field names in it. And the first time through, it's going to be object ID. Second time through will be shape, and so on and so forth. By putting .name, it puts them in a naming convention that we understand. If I didn't do that, it'd give it a naming convention that I don't understand what they mean. So this is sort of like the alias, if you will. Not really the alias, but similar to that. And if I run this, okay. I don't know if it, maybe it ran that quick. I don't think it did. Let's try this again. Run. Well, yeah, it did run that quick. I blinked and missed it. Okay, so you can see how that runs. You can look at all the files in that geodatabase that have Rush in its name because I used a wildcard here. So list feature classes. So what's all the files in the Indiana County geodatabase that have IN_Rush as part of the name at the beginning of the name? Well, there was 3 it came up with when I ran it. I could look at all the names of the cemeteries by using something called a search cursor, where the input is, again, the same file, same pathway that we talked about before. The output is going to be a file called name. That is the column that we're looking at. I'm sorry, this is not the output. The output is store. It's going to look at the column called name, and it's going to print each member of that column called name. So these are basically the rows as I'm looking at it. Pretty cool that you can do that without having to write extensive code. This notebook, as I said, gives me so much more power because I can see the net results immediately instead of having to wait around. So let me go back here for a second. Let me click on my map tab. So how did I get there? I went to Insert, New Notebook, and if you notice there's a pull down next to Notebook, and you can add a notebook that already exists, or you can create a new notebook. And if you create a new notebook, it's going to be about 10-15 seconds to create a new notebook. There is my new notebook. It happens to be over in the left-hand window, and these happen to be here. I can move it wherever I want to put it. There's nothing magical about where it's sitting right now. So notebooks become extremely powerful items in my mind. So I'm going to try to do this, and hopefully it will load quickly. I'm going to open a project. Unfortunately, I use bad naming convention. So I'm opening this project file that I have here. And let's look at something that's a little bit more complicated. But it sort of ties together what we can do. Okay, let me make sure I get to the right notebook. I think it's that one. Okay, so here you can see some code. It's got about 25 lines, including comments here. We're looking at a file of counties. So if you look at my location here, I'm looking at PLSS file of counties in Indiana. So this is basically just a 92 county map. So there's my pathway to it. I'm sorry, I was a line ahead of myself. Here's my pathway to where it's stored. And here's the file that I'm looking at. It's a polygon county map of Indiana. So it's got 92 counties there. And then what we do is we use the search cursor and we're going to get all the names of those counties. So we, instead of me having to input 92 names as a list variable, I can come in and get the names of the counties using my search cursor. So now I have the names of my counties. What I can do is then break each county up by individual name. First, I saved it as a shape file, and then I came back and put it into a geodatabase automatically. So I created both a folder that has 92 separate polygon files in it, but I also moved those files to a geodatabase. In fact, it's the geodatabase that we've been working with. I then took this information and I found out it wouldn't run for me. And the question that I had a few moments ago was, what about that space in that name? Well, there's a county in Indiana that its name is St. Joe or St. Joseph's, and they put a space in its name in this file. I had to go in and say, if the name is St. Joseph's, change it to being this name with an underscore in it, because I beat my head against the wall for a couple hours trying to figure out what was going on there. Then I came in here and I basically clipped out my data, and you can see these different pathways in here, but I clipped out my data for cemeteries. I clipped it out for water features. I did a bunch of different clips in here using some looping commands. And basically, when I came out of this, I started with one file. I ended up having 592 files or something like that. I had the county boundary files, I had the river boundaries, I had the polygon stream boundaries, I had the cemetery boundaries. It seems like there was one or two others that I had in there. Maybe I've taken them out of here. But by doing this, I had all these different files created all at once with basically about 22 functional lines of code if we get rid of the pounds that are in there and things. Some of the, and I should mention this, some of the pounds, like this one here, is just that I wanted to run only part of the script. I didn't want to run all the script. So if I take this pound out, it creates another 92. Creates the polygon boundary for streams. So by doing something like this, I got all this information. So how long did it take to run? About 45 minutes. I ran that, and it gave me the ability to do all the stuff I ever wanted for Indiana. Think if you take Kentucky, if you wanted all these as individual files that somebody could use, it would probably take you most of a week to do this manually. Besides the fact you'd be bored to death. The only thing I really have to change is where my incoming file is and some storage locations, and we could do this with any state. We could get parameters, get parameters in here, and would ask me where is my starting files instead of being hard coded like is in here. So that's sort of, where can you take this? Well, this is where I think you could take this. And again, it's not extensive lines of code. It's not difficult lines of code. There's no unique spatial statements in here. They're all pretty much basic statements like I talked about in other parts of this workshop. So with that said, I'm going to stop sharing my screen and see what kind of questions we might have and things. Cynthia asks, are these notebooks the same as Jupyter Notebooks? Yes, they are. There are also notebooks that you can now do out of ArcGIS Online. So there is a notebook there you can run out of ArcGIS Online. I've only played with them a little bit. I found that they were enough different that I think it would have to be a completely another module inside this model course, and probably will be at some point But I'm not sure when that might happen. There's also obviously notebooks you can get to outside of anything that's Esri that you can look at. And I've not played at all with anything of those type. So I've mainly worked with the notebooks inside, but the power versus what an IDE gives you or what the you get from Python inside ArcGIS Pro. Now, obviously, you can do a bunch of stuff with the labels and calculate field commands, but just look at the Python window or the IDE window. The nice thing with, again, everything that you do inside of a notebook is you can see the results immediately, and you got full code ability there. So what kind of questions do we have?
Yep, I don't see any other raised hands at this moment. If you do have a question, go ahead and raise your hand or type it in the
If we
chat.
can let people unmute if that's an ability at this point.
I think it is, yeah.
Wow, no questions.
Means you
Yeah.
did it right.
Or else I confused everybody.
So I have a question.
Mhm.
So have you worked with Python and pushing information and changing information in ArcGIS Online? That's something we have to do a lot of manual publishing. You know, whenever we run a tool in ArcGIS Pro to update some data, we have to republish that data ArcGIS Online. One thing we're looking at as a way to, like, whenever data gets updated is, you know, update symbology in ArcGIS Online, or, you know,
Mhm.
kind of have those two worlds speak a little bit nicer to each other without having to have so much manual intervention.
I have done a little bit with this. I have taken a file that was stored in a service. So I've taken a service, and inside that service, I've brought it in and did a buffering on ArcGIS, well, actually in a notebook. And you can actually do things from that direction. It was pretty straightforward, where I brought that service in, buffered it, and then saved it back up to AGO. So you can do some of that type of stuff, but the problem that I run into is permissions. And this is the same problem I'm running into with geocoding. That's the one section that's not done in this class is on geocoding. And the reason is trying to use ArcGIS Online's geocoder seems to give me some permission errors. The tokens aren't passing back and forth correctly. And that's sort of the same thing I was seeing when I was trying to pass the buffer back up to AGO, that there was a token issue there, but haven't spent enough time on it to be knowledgeable enough to be able to give you a definitive on how to do that.
Sure. Very cool. There is a question in chat now.
Okay, can we have both Python script for 32 and 64 installed on the same PC? Yes. So if you've got ArcGIS Pro and ArcGIS Desktop, you can have those both installed. The desktop, and I'm not positive on this, but I think this is correct. The desktop software generally has been installed first. So ArcMap has usually been installed first, and it goes into a folder called Python 227. When you install the ArcGIS Pro, it goes into a convoluted set of folders. So you have to really drill down. And so I showed you in, I think it's module 1, where that folder for Python 3.x is. 3.6 is what we're using right now. Where to go find that, but you have to show it where Conda is located so that it can then use it successfully in PyScripter. So you have to drill down. It's just not sitting out there like on a Python 36 folder like Python 27 is sitting there. So you do have to do a little bit of searching for it. But again, it's the pathway shown in module 1. Also, if you just sort of do a search for it, that's how I found it. I went on and just did a search for it, and it was pretty straightforward to find, but it took me a little while to find where it was at to tell Pi scripter to configure the 64-bit, but it's configured it called it a 64-bit, but it really was a 32-bit, the default configuration. And again, how I knew that was trying the print command in different ways. It worked the old-fashioned way. It did not work with the parentheses, which is the Python 3 way for print. Other questions for me today? Well, I will remind you that if you normally come to GeoEd, or if you've never came to GeoEd, it is going to be in early June, 7th, 8th, 9th, pre-conference on the 6th, and a post-conference on the 10th. Those conferences involve using the Google engine. On those, we have some outstanding speakers from across the world. And again, go to the webpage, the GeoTech Center, geotechcenter.org, and you'll find a link to register for the conference. And again, the conference is completely free. I think we'll have an upcoming professional development workshop that KAMP will put on in May, but we don't have a date yet for that. But I think we'll have another PD coming in May.
Yeah, that's right. That may be in conjunction with our quarterly meeting. We're kind of talking about that right now. We've got a couple of events coming up, hopefully followed that by another networking event. And then with the GeoTech, KAMP's going to have some involvement with that as well. So we're looking really forward to the GeoEd conference. And then one more thing. This is Andrew McKinney, current president of KAMP. I just want to say thanks a ton to Vince DiNoto, who's our current education and professional development chair, and Jessica Lott, our communications chair, for helping getting this going, putting this on for everyone. Lots of good information. I certainly enjoyed the parts that I was able to be here for. I hope you all enjoyed it. Look for more information on our conference this year. Obviously, this is last year was a weird year. This is an even weirder year with all the different, transitions and vaccinations and public gatherings and things like that. So just know that the board is currently looking at all the different options. So be prepared to hear more about in the coming months. So I just want to say thanks again, Vince, for putting on an awesome show as usual. But I'll let you end it. Looks like we're pretty close to it, so I'll pass it back to you.
Well, again, you're welcome to use the 9-course module. If anybody's looking for college credit for a Python class, this is actually our Python 255 class. And all you have to basically do is do the exercises listed in the 9 modules. And from that point, and sign up for the class, of course, and pay tuition. But this could be done for college credit. But the GeoTech Center has 11 model courses, and they're all being updated in different mannerisms. You'll see a brand new updated class in WebGIS coming probably by the end of the summer, if not sooner. So thank you, and have a great afternoon. What's left of it, at least.
Thanks, Vince. Thanks, everybody.